and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hello everyone, I am Surbhi Dhingra, Microsoft Technical Trainer here at Microsoft. I have a varied experience of 8 years in the industry and I love learning new things and then teaching them. I hold several Azure certifications from fundamentals like DP900, AZ900, SC900 to associate and expert level advanced role-based courses like AZ104, AZ204 and AZ400. I thank you so much for joining today and I welcome all of you to the Microsoft Virtual Training Days. Azure Data Fundamentals. This course covers 6 modules divided into 2 parts. Part 1 starts with Module 1, Explore Fundamentals of Data. In Module 2, we discuss exploring fundamentals of relational data in Azure. And we wrap up with Module 3, which explores fundamentals of non-relational data in Azure. After Module 3, we begin Part 2 of the course, starting with Module 4, which covers Explore Fundamentals of Large-Scale Data Warehousing. Module 5, Explore Fundamentals of Real-Time Analytics. And finally, we wrap up the course with Module 6, Explore Fundamentals of Data Visualization. We start from the very basics of data, answering questions like what is data, how does data look like, how to store it, and who works with data. And we move on to some advanced services in data. But remember, we're doing the fundamentals, so we sail mostly at the surface to dig deep. Any concepts, anytime. MS Learn is our official documentation to prepare for our courses, and MS Learn will be your best friend. So let's get started with Module 1. So this is Microsoft Azure Virtual Training Day, and this is our course agenda that we already talked about. We're going to cover 6 modules in 2 parts. There goes the Module 1, Explore Fundamentals of Data, where we're going to talk about core data concepts and set some fundamentals like what is data, how is it stored, and a few more interesting ones. Then we'll discuss the data, roles, and services that you can choose after studying data. We'll start with our first lesson, core concepts of data, with a very important question, and of course, the most basic one. What is data? Now think about data as any collection of facts. These can be numbers, descriptions, observations used to record information. And you are recording information in terms of entities, having one or more attributes or characteristics attached to it. For example, the data important to any organization would be its list of customers, list of products, list of sales orders, and so on. There are all entities that I'm talking about. Now, in a list of customers, a customer might have a name, address, a phone number, an email address, and so on. These are all the attributes of that customer. So there are 2 terms here. We are recording information in terms of entities that can have one or more attributes. Okay? Now you know what data is. Let's think about how does the data really look like. Any type of data that you see would be either of these 3 that you see on the screen: structured data, semi-structured data, and unstructured data. Let's look at these one by one. Structured data. This structured data, as by the name, it adheres to a fixed schema. It follows a fixed structure. So all of the data will have the same fields or properties. This is often stored in database tables with rows and columns. And multiple tables can reference from one another using key values. For example, in SQL, you have databases. Tables have a schema with rows and columns, where every row has same fields. While on the other hand, the semi-structured, as clear from the name, is the information that has some structure but allows some variation between the entities. This is a more flexible option. For example, most customers may have an email address, some might have multiple email addresses, and some might have none at all. So all these instances can have their places on the same file. You don't have a strict schema to follow. Best example is the JSON file in front of you. We'll take a little bit more about it in a little while. But on the other extreme, if you observe, is the unstructured data. Unstructured data, again by the name, it does not follow any schema. Any data that is stored without a schema to organize the discrete values. The examples are your documents, images, audio, video, binary files, text files. Anything that does not fall into the structured and semi-structured data is your unstructured data. I hope you're all with me till now. Next, we will look at how is data being stored. Just think for a moment, where would you store your data? If you're thinking files or databases, you're right. Let's talk about the files first. Files can be stored in your local file systems on the hard disk of your personal computer, USB drives, shared file systems, central storage location in the cloud, while the option cloud being the cost-effective, secure, and reliable storage solution for large volumes of data these days. The specific file format that you use to store data will depend on multiple factors. The type of data being stored, is it semi-structured, structured, or unstructured? What kind of applications are going to read, write, and process this data? Who needs to read these files, humans or computers? Based on all these factors, we are going to discuss the most popular file formats here. First, being the delimited text files. In these types of files, the data is stored in the plain text format with specific field elevators and row terminators. It is simply called delimited because we're using delimiters or commas to separate the values of the fields. The most common format for these types of files is CSV files. You must have heard of comma-separated files, in which the fields are separated by commas and rows and are terminated by a new line or a slash. Optionally, the first line may include the field names, and the other common formats like this would be TSVs, tab-separated values. Delimited text is a good choice for JSON, JavaScript Object Notation. This is a very famous hierarchical document format which is used to define the data entities which has multiple attributes. It's a very flexible format and is good for both structured and semi-structured data. In the example, observe that the objects are enclosed in braces like the customer, and the collection, which is say the contact, they are added in the closed square brackets. And attributes are represented as a key value pair separated by commas. Next is XML. This is also a very famous human readable data format. It's called extensible markup language. This is largely in this format that the data is enclosed in the angle brackets. We use tags to define the elements and attributes as shown in the example. It's a similar data, but it's just represented in the XML language. Ultimately, all the files are stored as binary data, but in the human readable format, the binary data are mapped to printable characters. Some file formats, specifically for unstructured data, they store the data as raw binary. which must be interpreted by the applications. Very common type of examples are images, videos, audio, and application-specific documents. We also call them blobs in short, the binary large objects. These were some of the examples which are human-readable formats, while human-readable formats are structured and semi-structured that typically not optimized for storage space. And processing, sometimes you must enable compression or enable indexing for efficient storage and processing. These are called optimized file formats. The examples are Avro, ORC, and Parquet. The Avro is a row-based format. It was created by Apache, and ORC and Parquet are the column-based formats. Avro is a very good format for compressing data and minimizing storage in the network bandwidth requirements, while in the ORC, the data is in 2 columns rather than rows. Parquet file includes the metadata that describes a set of rows found in each chunk. The application can use this metadata to quickly locate the correct chunk for a given set of rows and retrieve the right data. It supports very efficient compression, encoding schemes, and let's think of what is the other way of storing and managing the data. Databases. Databases are used to define a central system where data can be stored and queried majorly. There are 2 types of databases that we talk about: relational databases and non-relational databases. Relational databases are most used to store and query structured data. This data is stored in tables that represent entities. Each instance of this entity is assigned a primary key which uniquely identifies this data, and this key is used to reference the other instances. And just observe the example on the screen. The customer's primary key ID can be referenced in the sale order to indicate which customer placed which order and when. This also eliminates the duplication of data. Now, the details of the customer is only stored once in the customer table. These tables can be queried using the SQL. You must have already heard or used SQL. It is your structured query language. The SQL is relational databases. On the other hand, the data management systems that do not apply a relational schema to the data, we call them non-relational databases or NoSQL databases. Better for common types of non-relational or NoSQL databases. Commonly in use, the first 20 already, you must have already seen it as a simple key value format. The key is unique and every key has an associated value to it. Next is the document databases, which are very specific form of a key and database. The best example is the JSON. Then you have the column family databases, where the tabular data is having the rows and columns, but you can divide them into columns and families. Like you can divide this customer as one family and product as another, and they're logically related using the keys. Then you have graph databases, where your entities as nodes are interlinked. Ben works in the hardware and reports to Sue. So these are some of the basic about relational and non-relational databases. We are heading towards a very important concept, which will be briefly touching it here because we're covering all these in the later modules. The first one is what is the transactional data workloads. As the name clarifies, this is a transaction going on. The transaction could be financial. For example, the movement of money between accounts in any banking system or a retail system. These transaction systems are mostly high volume, so sometimes they handle millions of transactions in a single day. This works performed by these transactional system is often referred as OLTP, which is online transactional processing. OLTP solutions, they rely on a database system which is optimized for both read and write operations. They are also supporting workloads in which data records are created and retrieved and updated and deleted, the CRUD operations as we call them. Now, to ensure the integrity of these millions of transactions happening in the database, we enforce ACID semantics. You might have already heard of this term ACID. There are 4 terminologies related to it. This is very important now. I want all of your attention here. What is ACID? In ACID, A is for atomicity, C is for consistency, I is for isolation, and D for durability. Now look at all of these one by one. First, the atomicity. Just understand the term by its name, that every transaction is treated as a single unit. It's a single unit, so it will either succeed or fail completely. For example, if it is a money transaction that is debiting the fund from one account and crediting the same amount in the another account, these are both parts of one single unit. If either action cannot be completed, then the other action must also fail. It's not like it is debited, but it is not credited to the another account. Both of these steps are a part of one single unit, and this is an atomic transaction. The transaction has to succeed completely or fail completely. Then we have C for consistency, where the transaction can only take the data in the database from one valid state to another. Let's continue the debit and credit example that we used earlier. Let the completed state of the transaction must reflect the transfer of funds from one account to another. If I am sending you $100, you are also getting the same amount to the changes that are debited. Enter the credited end. Both of these changes are consistent. Isolation is your concurrent transitions. They cannot interfere with each other. As clear from the name itself, these are isolated transactions. So while the transaction is transferring the fund from one account to another, is in the process, if there is any transaction that checks the balance, it will return the consistent result. Next is durability. When a transaction has been committed, it will remain committed. What does durability generally also means? It's that your data persists where we are talking about transaction. So your transactions are persisted in the database. Even if your systems were to be switched off, the transactions that are already committed, you will see the database will reflect those transactions when it is turned on again. So these are the 4 properties which are very important, and you need to understand all of these for 4 terms for your OLTP systems, which are your online transaction processing systems. Moving on to the next concept, we have analytical data workloads. Analytical is data processing here. We are analyzing data. So it's mostly read-only data that you're talking about. So it's the vast volume of data that we're reading to form an analysis. This diagram that you see on this screen is very important. We will get into the detail of this in our part 2 of the course. Today, I'm giving you a brief idea of what it is all about. In the first step, these other data files that may be stored in the central data lake for analysis, then your data can be loaded into a data warehouse which is optimized for read activity. Third step is the data warehouse can be aggregated and loaded into an OLAP model. Now, what is this OLAP model? It is Online Analytical Processing Model, or a cube, as you can see the shape of it in the aggregated numerical values from the fact table, a calculated one, and then the data in the data lake and the data warehouse and analytical model. It can be queried to produce reports, visualizations, and dashboards, as you can see in the step 4. Let us continue the example of the customer in the product from the previous slides. You have all the customer and product data stored in your data lake. This is a read only. Notice data if you want to calculate the sales revenue by date, or which customer ordered what, how many products have been sold. All of this you can process in the cube. And with all this processing done, if you want to generate reports, you can do that on your dashboards. I wouldn't dig deeper right here because all these concepts will make more sense when discussed in the part 2 of our session. So what is the key takeaway from this slide for you is that you will have analytical data processing in these 4 steps, where you have a data lake, data warehouse, in the cube, and the dashboards, and the rest will pick up from here later. Moving on to the lesson 2, data roles and data services in Azure. There is a wide variety of roles involved in managing, controlling, and using data. Some rules are business-oriented, some involve more engineering, some focus on the research, some are also hybrid that combine multiple roles of data management. Your organization may define these rules differently. There might be different names, but the most common divisions are database administrator, database engineer, and data analysts, where data administrators are supposed to manage databases, assign permissions to users, data backups, performance, monitoring, data optimization, where the data engineer, on the other hand, takes care of the data integration, pipelines with ETL, apply data cleansing routine, implement pipelines to transfer and transform data between systems. Where, on the other hand, the data analysts, they explore and analyze data to create visualizations in charts that enable organizations to make informed decisions. This slide shows the most common services in Azure that deals with data. Now, don't get overwhelmed by the number of services shown if you don't know them, or if you have looked at these, they are all feeling new to you. We're going to cover these services in our coming modules. So I would not be going into detail right away, but we'll touch them briefly. So in the order, Azure SQL, this is your collective name for a family of relational databases. But just consider the ways Microsoft SQL, Server Database Engine specifically, Azure SQL Database, which is a fully managed PaaS database, SQL Managed Instance. This isn't a hosted instance of SQL Server with automated maintenance. Azure SQL VM do the installation of SQL Server on it. Then we've got Azure Databases for the open source relational databases. And we have relational databases like MySQL, MariaDB, PostgreSQL. Although the popular open source is relational database systems, we have their Azure databases as managed services. So just understand them being a wrapper over the open source database management systems. The Azure Cosmos DB, on the other hand, is a global scale non-relational database system. We're going to cover this in module 3, but the data here is getting stored in JSON documents. This is, no SQL database. Then we have Azure Storage. This is the core of Azure services that enables you to store your data in file shares, global file shares, tables. What is the most widely used service in Azure? Azure Storage. Then you have Azure Data Factory that enables you to define and schedule pipelines, to transfer data, to transform data. Then you have Synapse Analytics, which is a comprehensive analytics solution, and it's got multiple capabilities like pipelines, SQL Apache Spark, then Apps Data Explorer. Then you've got Azure Databricks, which is an Azure integrated version of the popular Databricks platform, which combines your Apache Spark processing platform with SQL database semantics. This is meant to enable large-scale data analytics. Then you've got HD Insight, which is again a Azure hosted cluster from popular Apache open source big data processing technologies like Apache Spark, Apache Hadoop, patch-based Kafka, Storm, or HD Insight you can think of as a solution for your Apache open source big data processing in Azure. Then we've got Stream Analytics. The Azure Stream Analytics is a real-time stream processing engine. It'll capture a stream of data as an input and apply or query to extract and manipulate the data explorer. This is a standalone service which offers the high performance querying of logs and telemetry data. That you got Microsoft Purview, which provides a solution for enterprise-wise data governance and discoverability with Microsoft Power BI. This is a very powerful platform for analytical data modeling and reporting, mostly used by that analysts that we talked about who can create and share data visualizations. And there are multiple desktop applications and mobile applications where you can create and view your reports. Very interesting bunch of services that we have got in Azure, and I'm sure you will be happy to explore them with me. We will take a quick 10 minutes break and start back with Module 2, Explore Fundamentals of Relational Data in Azure. Stay tuned. Welcome back from the break. This is Microsoft Azure Data Fundamentals Virtual Training Day, and this is Module 2, Explore Fundamentals of Relational Data in Azure. This is a very straightforward module where we will discuss the relational data concepts, and then we'll move on to explore some Azure services that provide solution to relational databases. Let's begin with our first lesson to explore relational data concepts with some characteristics of relational data. In a relational database, your model contains collections of entities from the real world as tables, where entity is any important object or event that you want to record. For example, in a retail system, the table of customers, products, orders, line items, all are entities. Our table contains rows, and each row represents a single instance of an entity. In this scenario, each row in the customer table contains the data for a single customer. Each row in the product table defines the single product. Similarly, each row in the order table will represent an order made by the customer. Now, if you observe these tables closely, you would notice that every row has the same columns, but these columns may vary in the values. For example, in this table of customers, there's no middle name with the customer named Samir. Also, these customers are identified by unique primary keys, which is ID in this case. This key is used to reference the following customers in other tables, like the order table, where the customer ID shows the order number and the order date by this respective customer. This model reduces data duplication because one table is able to reference another. Also, each of these columns will have a specific data type. For example, the email column in a customer table would likely to be defined to store the character-based, the text data, which might be fixed or variable in length. A price column in the product table might be defined to store decimal numeric data, while a quantity column in the order table might be constrained to integer numeric values. And the order date column in the same order table would be defined to store the date and time values. The available data types that you can use when defining a table depend on the database system that you're using. Though these are all standard data types defined by the American National Standards Institute, ANSI, that are supported by most database systems. Moving on to another important term, normalization. This is a common term used by database professionals for a schema design process that minimizes data duplication and enforces data integrity. While there are many complex rules that define the process of refactoring to levels of normalization, a simple definition would be you should separate each entity into its own table. You should separate each discrete attribute into its own column. Uniquely identify each of the instance using a primary key. We should use the foreign key columns to link related entities. To understand the core principles of normalization, suppose the table on the left represents the spreadsheet that a company uses to track its sales. Notice that a customer and product details are duplicated for each individual item sold, and that the customer name and postal address and the product name and price are combined in this same spreadsheet cells. Now, look at how it is normalized. The normalization has changed the way the data is stored. Each entity that is represented in the data, customer, product, sales order, line item, is stored in its own table, and each discrete attribute of those entities is in its own column. Instances of each entity are uniquely identified by an ID or other key value, And when one entity references another, for example, an order has an associate customer, the primary key of the related entity is stored as a foreign key. So we can look up the address of the customer, which is stored only once, for each record in the order table by referencing the corresponding record in the customer table. Typically, a relational database management system, the RDBMS as we call it, can enforce referential integrity to ensure that a value entered into a foreign key field has an existing corresponding primary key in the related table. For example, preventing orders for non-existing customers. So that's normalization. I hope it's all making sense right now. That is normalization. Moving on, SQL. SQL is a standard language for working with relational databases with syntax standards that are maintained by the American National Standards Institute, ANSI, and International Standards Organization, ISO. Most relational database systems vendors extend the standard language with some proprietary syntax. For example, Transact SQL, the TSQL, Microsoft SQL Server-based systems, PLSQL, Oracle, PostgreSQL. These are three broad types of SQL statements that can be used in database system. Now focus here. These are the three things I want you to take away about SQL: DDL, DCL, and DML. Let's focus on them one by one. DDL is data definition language. Because it is definition language, you are defining and managing your tables in the database here. For example, you can create new objects and alter or drop existing objects. The example on the slide shows a create table statement used to create a new empty table named product with ID, name, and price as the fields or columns. Next is DCL, the data control language. Focus on the control word here and the lock sign on the slide. It is used to manage or control the access to objects in the database. You can grant, deny, or revoke specific permissions for specific users or a group of users. The example on the slide grants the user 1 with the permission to use, select, insert, and update statements on the product table. All right? Then we have the DML, data manipulation language. Again, focus on the word intending manipulation of data. This is the most commonly used type of SQL and is generally used to insert, update, delete, or select data in the tables. The example on the slide assumes that some data has previously been inserted into the product table and shows the results returned by a select query that will retrieve the name and price of all products with a price greater than 2.50 sorted in the order of price. This slide shows you a core set of SQL statements and examples. The SQL language is intensive and there are other statements that are not shown here. Additionally, the syntax for the statements that are shown here can be much more complex than these simple examples. If you're interested in exploring SQL beyond this data fundamentals course, we have specific SQL courses that you can check out on the MS Learn. In addition to tables that we just saw, databases can contain other kinds of objects that enable you to work with data. Views. Views are predefined SQL select queries that return a tabular data set. Views behave as virtual tables, and you can query them using select statements just like other tables. They are often used to abstract the normalized schema of the database to encapsulate data from one or more tables. On the other hand, the stored procedures, these are the predefined SQL statements that can be run on demand. Just like scripts, they can be parameterized and are often used to encapsulate data operations, to insert, delete, or update records for data entities. Then, indexes are tree-based structures that enable the database query engine to find individual records based on specific column values, more quickly than if they just read the entire table. These types of database objects and others enable you to build a comprehensive relational database that applications can use to store, manage, and retrieve details of entities efficiently and securely. So that brings us to the end of lesson 1, and we now move on to the lesson 2. Explore Azure services for relational data. In this module, we will discuss the various relational database services we have in Azure. But just remember, these are not all. We've got a lot more in Azure, but we'll definitely stick to the ones important here. Excited? Let's move on. Azure SQL. Azure SQL is the generic term used to describe a family of Azure relational database services that are based on Microsoft SQL Server. SQL Server is an industry-leading relational database management system that is used in on-premises solutions by some of the biggest organizations in the world. The Azure SQL services are based on the same database engine, making them a great solution for organizations that want to migrate existing on-prem databases to the cloud, as well as the new applications that are designed as cloud-based from conception. On the left is your IaaS solution SQL Server, and on the right, both of SQL Managed Instance in Azure SQL Database are your PaaS offerings. We'll talk about them one by one. SQL Server on Azure Virtual Machines is an infrastructure as a service solution, the IaaS, in which a full instance of SQL Server is installed on a VM, the virtual machine that is hosted on Azure. This makes it a good candidate for migrating projects where one-to-one compatibility with an existing on-prem SQL Server instance is required, or for hybrid scenarios with a mix of cloud-based and on-prem databases that must maintain compatibility. Because it is an IaaS solution, you have full control of the configuration of the database, which also means you have responsibility to manage administrative tasks, just as you would do for a SQL Server instance in your own data center. Costs for the service are based on SQL Server licensing and the cost of running the VM in Azure. On the other hand, Azure SQL Managed Instance is a platform as a service that enables you to pre-provision compute resources and deploy several individual SQL Server managed instances up to your pre-provisioned compute level. Core administrative tasks are automated while providing a high degree of compatibility with on-prem SQL Server. You can choose to deploy a single managed instance that supports multiple databases, or you can create a pool of instances that share underlying infrastructure. For cost efficiency, SQL Managed Instance is a great choice for most migration scenarios, where you need to move an on-prem SQL Server database to the cloud with minimal changes. Azure SQL Database is another platform as a service solution that offers the lowest cost Azure SQL option. You have minimal administrative control over the service beyond creating the database schema, importing and exporting data, and configuring the access controls. Azure SQL Database enables you to deploy a single database or an elastic pool that share resources across multiple databases. Azure SQL Database is a great choice for new application that requires a low-cost relational data store with minimal administrative overhead. The list is in the decreasing order of administrative control or responsibility and cost. The SQL Server on a VM is the most expensive option, but allows you great control over server and database configuration. However, you also have full responsibility for server maintenance and management. Azure SQL Database is the lowest cost option, but it supports fewer configuration options. Most database maintenance, other than access control, is all automated for you. SQL Managed Instance offers a balance of both cost, administrative control, and maintenance automation. Now that we understand what are these services and what they offer, important question is when to choose which service. Let me tell you simple scenarios to help you make the right choice for yourself. This is also an official recommendation that you should use SQL Server on Azure VM option when you need to migrate or extend an on-prem SQL Server solution, and you want to retain full control over all the aspects of server and database migration. You should use the Azure SQL Managed Instance option for most cloud migration scenarios, particularly when you need minimal changes to existing application, and you go for SQL Database for new cloud solutions or to migrate applications that have minimal instance level dependencies. I hope that was of help. MySQL started life as simple to use open source database management system. It is commonly used in Linux, Apache, MySQL, and PHP, the LAMP stack apps, as we call them. Benefits of Azure Database for MySQL. You get the following features with Azure Database for MySQL. High availability features, these are built in. You get a predictable performance, easy scaling that responds quickly to the demand, secures data both at rest and in motion. You get automatic backups and point-in-time restore for the last 35 days, while MariaDB is a newer database management system created by the original developers of MySQL. The database engine has since been rewritten and optimized to improve the performance. MariaDB offers compatibility with Oracle Database, which is another popular commercial database management system. Azure Database for MariaDB, it delivers built-in high availability with no additional cost, gives you predictable performance using inclusive pay-as-you-go pricing, scaling as needed with seconds, and you can secure the protection of sensitive data at rest and in motion. You get automatic backups and point-in-time restores for up to 35 days. Enterprise-grade security and compliance. On the other hand, PostgreSQL is a hybrid relational object database. You can store data in a relational table, but a PostgreSQL database also enables you to store custom data types with their own non-relational properties. Azure Database for PostgreSQL is a highly available service. It contains built-in failure detection and failover mechanisms. Users of PostgreSQL will be familiar with the pgadmin tool, which you can use to manage and monitor a PostgreSQL database. You can continue to use this tool to connect to Azure Database for PostgreSQL. However, some server-focused functionality, such as performing server backup and restore, aren't available because the server is managed and maintained by Microsoft. Pretty cool, right? We will now see a demo where I'll provision an Azure SQL database resource in my Azure subscription, and then I'll use the SQL query to query the tables in a relational database. If you're comfortable, you can do this along with me in your Azure subscription. The instructions can be found on the MS Learn. Let's get started. All right, so this demonstration is all about creating Azure SQL database resource. If you find the pace right, you can also do this along with me, but you can do this later as well from the Microsoft Learn sandbox. Just remember, Microsoft Learn is your best friend to practice your labs. It provides you with the sandbox for all the demonstrations that we're going to do in this course, and you can perform them by yourself with all the instructions. All right, so let's begin. Log into the Azure portal, the portal.azure.com, select or search for Azure SQL service, click on create. You will see these three options: SQL databases, managed instances, and virtual machines. Just on the left, we will be selecting the SQL database. Just make sure the single database is selected and click on create. Choose a subscription in the basics of your choice. If you're using the sandbox environment, you will already have a subscription created. It's called the Concierge subscription. And there will also be a resource group with the name learn-something something. So just select that. I am using my own subscription and my resource group for this. Give a database name. This could be any name. I'm just writing something random. Just choose the name that you prefer. Then you have to create a server. Let's click on create a new server. Give the server name. It has to be a unique name. Specify a location that you're comfortable with. Use the SQL authentication here and give the admin login details. Just put the name and password here. Remember to note down this password somewhere because we will be needing this. Confirm your password again. And OK. This would create a new SQL server for you, of which your SQL database would be a part of. Do you want to use Elastic Pool? No. Compute and storage, just keep it as it is. Backup storage redundancy, we will choose the locally redundant storage, which is the LRS option. Because this is a sample one that we're creating, we do not need multiple redundancy options. Moving on to the networking. We want a public endpoint, and you have to select the yes option in both the firewall rules so that you allow your access to your database server from the Azure services and also your current client IP address. You wouldn't be able to log in without these. Then moving on to the security option. We do not want the defender, so please select not now here. Rest other things will leave as the default settings. Come to the additional settings tab. In this page, we are going to use the existing data from sample. You can also bring up your backup data in this one, but we are going to use the sample because it will create a sample database which we can explore later on. And as soon as we create a sample database here, the compute and storage settings in the basics, it'll automatically be backup compatible. Just click on OK, skip the tags, review and create, and click on create. Once you click on create, you'll have to wait for the deployment to complete and come back to your service. Just to save time, I have already created one database server. I'll move on to this SQL databases. This is my SQL database. It has a similar configuration of what we have just created. Here you will see a query editor in the left pane. Just click on the query editor preview. Give your name and the password. And click on OK. This should log in you to your SQL database. If you're doing it for the first time, we'll see this error saying client with IP address is not allowed to access the server. Just simply click on the end allow list link and try logging in again. Because we enabled the firewall, so this should ideally work. Now, in the left pane, expand the table folder to see the tables in your database. Remember, we selected a sample one, so there should be a list of sample databases. There you go. Then, in the query pane, you can run your preferred queries. This is simple query select star from sales lt.product. It simply says, I want the content, star is for all, from sales lt.product, which is the table name here. When you run the query, you will be able to review the results of this query just at the bottom in the result pane. I would rerun the query and we can still see the results. Then I have another query with me. We'll just replace this current select query with the statement saying select product ID, name, list price, product category from sales lt.product. So with this statement, what we're trying to do is we're going to get only the product ID, name, list price, and product category. Only the 4 columns from this whole list. Select your query and run it. The query is running, it will take a few seconds and it will respond with the 4 columns that we asked for. Now let's try another query which uses a join statement to get the category name from the sales LT product category table. I'll just replace the query here. Now, so what this query is doing, this is selecting your product ID, name as a product name. So this is creating a new view, name as category with list price from the product and joining it with the product category as C. So we're using a join statement, getting columns from the table and joining it with the product category ID. So here's the product ID, product name, category, and the list price. That's all for today's demo. Close the query editor pane, discard your edits. If you use your own subscription, make sure you delete the resource group that you created. And I hope it was useful. That wraps up our module 2. We learned some relational database concepts like tables, normalization, SQL concepts, the DDL, DCL, and DML. Then we discussed the services in Azure that helps you build your relational database solutions. This brings us to the end of this module 2. We will take a quick 10 minutes break and start back with our module 3, explore fundamentals of non-relational data in Azure. See you soon. Welcome back from the break. This is Microsoft Azure Data Fundamentals Virtual Training Day, and we are at Module 3, Explore Fundamentals of Non-Relational Data in Azure. Most software applications need to store data. Often this takes the form of a relational database, in which the data is organized in related tables and managed by structured query language, SQL. However, many applications don't need the rigid structure of the relational database, and they rely on non-relational, often referred as the NoSQL database or storage. And rigidity in relational databases can often lead to poor performance unless you spend time implementing detailed tuning. Other models, collectively known as NoSQL database, exist. These models store data in other structures such as documents, graphs, key value stores, and column family stores. So, in this module, we will explore fundamentals of non-relational data in Azure, where we talk about two non-relational services in Azure. One is a storage, so that's our first lesson, fundamentals of Azure storage, and lesson 2 will cover Azure Cosmos DB. Azure Storage is one of the core services in Microsoft Azure and offers a range of options for storing data in the cloud. In this module, we'll explore the fundamental capabilities of Azure Storage and learn how it's used to support applications that require non-relational data stores. Starting with the first service, that is Azure Blob Storage. This is a service that enables you to store massive amount of unstructured data. Remember, unstructured data or blobs in the cloud. Inside an Azure Storage account, you create blobs inside containers. A container provides a convenient way of grouping related blobs together. And you can organize blobs in a hierarchy of folders, similar to files in a file system on a disk. You control who can read and write blobs inside the container at the container level. Azure Blob Storage supports 3 types of blobs: block blobs, page blobs, append blobs. A block blob is handled as a set of blocks. Each block can vary in size, up to 100 MB. A block can contain up to 50,000 blocks, giving us a maximum size of over 4.7 TB. That's simply block size into 50,000 blocks. The block is the smallest amount of data that can be read or written as an individual unit. Block blobs are best used to store discrete, large binary objects that change infrequently. Page blobs. A page blob is organized as a collection of fixed size 512 byte pages. A page blob is optimized to support random read and write operations. You can fetch and store data for a single page if necessary. A page blob can hold up to 8 TBs of data. Azure uses page blobs to implement virtual disk storage for your VMs. So the best use of page blobs is to use it with your virtual machines. Then comes your append blobs. An append blob is a block blob optimized to support append operations. You can only add blocks to the end of an append blob. Updating or deleting existing blocks is not supported. Each block can vary in size up to 4 MBs. The maximum size of an append blob is just over 195 gigs. So append blob is basically used for logging purposes. So how do you decide which blob to use? If you're using VHD files for the disks for the VM, go for page blobs. If you're looking for logging scenarios, go for append blobs. If not both of these options, just simply choose the block blob. Moving on, blob storage provides 3 access tiers, which helps you to balance the access latency and the storage cost. So the hot tier is the default one. You use this tier for blobs that are accessed frequently. The blob data is stored on high performance media. The cool tier has a lower performance and incurs reduced storage charges as compared to the hot tier. Use the cool tier for data that is accessed infrequently. It's common for newly created blobs to be accessed frequently initially, but less so as the time passes. In these situations, you can create the blob in the hot tier, but migrate it to the cool tier later. You can migrate a blob from the cool tier back to the hot tier as well. The archive tier provides the lowest storage cost, but with increased latency. The archive tier is intended for historical data that must not be lost, but it is required only rarely. Blobs in the archive tier are effectively stored in an offline state. So typical reading latency for the hot and cool tier is a few milliseconds, but for the archive tier, it can take hours for the data to become available. To retrieve a blob from the archive tier, you must change the access tier to hot tier or cool tier. The blob will then be rehydrated, and you can read the blob only when the rehydration process is complete. You can also create a life cycle management policies for blobs in a storage account. A life cycle management policy can also arrange to delete the outdated blobs. Moving on to Azure Data Lake Storage Generation 2. So Azure Data Lake Storage Gen 1 is a separate service for hierarchical data storage for analytical data lakes, often used by so-called big data analytical solutions that work with structured, semi-structured, and unstructured data stored in files. Azure Data Lake Storage Gen 2 is a newer version of this service that is integrated with Azure Storage, enabling you to advantage of the scalability of blob storage and cost control of your storage tiers, combined with the hierarchical file system capabilities and compatibility with major analytics system of Azure Data Lake Store. Systems like Hadoop in Azure HD Insight, Azure Databricks, and Azure Synapse Analytics can mount a distributed file system hosted in Azure Data Lake Storage Gen 2 and use it in a process to process huge volumes of data. To create an Azure Data Lake Storage Gen 2 file system, you must enable the hierarchical namespace option of an Azure storage account. You can do this when initially creating the storage account, or you can upgrade an existing Azure storage account to support Data Lake Generation 2. Note that upgrading is a one-way process. After upgrading a storage account to support a hierarchical namespace for blob storage, you cannot revert it to a flat namespace. Azure Files is essentially a way to create cloud-based network shares, such as you typically find in your on-prem organizations, to make documents and other files available to multiple users. By hosting file shares in Azure, organizations can eliminate hardware cost and maintenance overhead and benefit from high availability and scalable cloud storage for files. You create Azure File Storage in a storage account. Azure Files enable you to share up to 100 TB of data in a single storage account. This data can be distributed across any number of file shares in the account. The maximum size of a single file is 1 TB, but you can set quotas to limit the size of each share below this figure. Currently, Azure File Storage supports up to 2,000 concurrent connections per shared file. Azure Files supports two common network file sharing protocols. SMB file sharing is the most commonly used across multiple operating systems, Windows, Linux, Mac OS. NFS shares are used by Linux and Mac OS versions. To create an NFS share, you must use a premium tier storage account and create and configure a virtual network through which you can access the share and you can control it too. In an Azure table storage, items are referred to as rows and fields are known as columns. However, don't let this terminology confuse you by thinking that an Azure table storage table is like a table in the relational database. An Azure table enables you to store semi-structured data. All rows in a table must have a unique key, which is composed of a partition key and a row key. But apart from that, the column in each row can vary. Unlike the traditional relational databases, Azure Table Storage tables have no concept of relationships, stored procedures, secondary indexes, or foreign keys. Data will usually be denormalized, with each row holding the entire data for a logical entity. For example, a table holding customer information might store the first name, last name, one or more telephone numbers, one or more addresses for each customer. The number of fields in each row can be different, depending on the number of telephone numbers and addresses for each customer. And the details can be recorded for each address. In a relational database, this information would be split across multiple rows in several tables. To help ensure fast access, Azure Table Storage splits a table into partitions. Partition is a mechanism for grouping related rows based on a common property or a partition key. Rows that share the same partition key will be stored together. Partitions not only help to organize data, it can also improve scalability and performance. Partitions are independent from each other and can grow or shrink as rows are added to or removed from a partition. A table can contain any number of partitions. When you search for data, you can include the partition key in the search criteria. This helps to narrow down the volume of data to be examined and improves the performance by reducing the amount of IOPS, the input-output reads and writes, needed to locate that data. The key in the Azure Table Storage table comprises of two elements: the partition key that identifies the partition containing the row, as we just described, and a row key, which is unique to each row in the same partition. Items in the same partition are stored in row key order. If an application adds a new row to a table, Azure ensures that the row is placed in the correct position in the table. This scheme enables an application to quickly perform point queries that identify a single row and range queries that fetch a contiguous block of rows in a partition. We will now see a demo where I'll provision an Azure storage account in my Azure subscription and explore the various ways that we can use it to store the data. If you're comfortable, you can do this along with me. The instructions can be found on the MS Learn. Without further ado, let's get started. All right, so let's begin this. We will log into the Azure portal, portal.azure.com. And on the home page, you can either click on Create a Resource on the upper left corner and search for the storage account, or simply in the search bar write Storage Account. Click on Create. Now in the basics, it'll always ask you for a subscription and a resource group. If you're using the sandbox on the MS Learn, you should select the Concierge subscription. Otherwise, select your Azure subscription that you have. Also, if you're using the sandbox, the resource group is already created with the name learn-something. Otherwise, you can create a new resource group. Just simply name it and click on OK. So that's the basic detail you have to give it. I have created my resource group with the name DP900. We have to give a storage account a good unique name. So we can try a name. Let's see if it allows us. The product sample storage. Select a region of your choice. I'm going with East US. Let the performance be standard. We'll choose the redundancy to locally redundant storage. We do not need multiple copies of this. Is anyway a sample storage account we are creating. Then select advanced. You have to view the advanced configuration options. Just look at them carefully. In particular, you got to note this setting, the data lake storage generation 2. Just leave this option unselected for now. I'm just showing you that this is the place where you enable this hierarchical namespace. If we enable it, we can use it for data lake storage, which accelerates our big data analytics, and it will also enable the file level ACLs. We can do the setting later as well, so we'll skip this for now. Next, networking. Just view all the options, the networking options available for the storage account. We are enabling all the public access for all the networks. Next is your data protection tab. This tab is enabling the soft delete options for the recovery. This is simply, if you enable them, these are enabled by default for 7 days. That means all your deleted files or blobs or containers, they will be retained for the next 7 days for you to undelete them and put back to your containers. So it's just like a recycle bin where your deleted files are saved for a temporary amount of time. You can change this number as well. But because this will cause some issues later when we enable the hierarchical namespace, so I am going to disable these settings, all of them. And we go to the next options. We keep the encryption options as it is. Skip the tags, review. Once all the information is put in, you can review your information and click on create. Now you have to wait for the deployment to complete. Once this deployment gets complete, which takes about 2 to 3 minutes, not a lot of time, you have to go to that resource which we have deployed. So just for the saving time, I already have one storage account created with the similar settings that we have just did. Now look at how this storage account looks like. This is the overview tab. It is showing us all the options on the left menu. Okay, that storage account is already built, so it didn't even take 2 minutes. See, it's that simple and quick. Now observe the data storage part of it. You've got containers, file shares, queues, tables, all of it in one bucket. So these are all part of your storage account. We will first talk about the containers. Select containers. To create a container, you will simply have to click on this plus sign, give a name, give it a public access so that we are able to access it via browser. If not, we can simply put it to private, no anonymous access. And simply click on create. This creates your container. Now if we go back to the left pane, you would see a storage browser here. Click on this storage browser, and this will show you how much of data that you have. Because it is a new storage, these are all empty, but as soon as you create containers, you upload blobs, it will show you all the content at one place. If you click at blob containers, you should see the container that we've just created, the data container. It is listed. Let's select the data container. Because we haven't really uploaded anything, so it's empty. Let's click on Add Directory. We'll give it a name, Products. We are adding a folder here named Products. Now in the Storage Explorer view, if we go back to the blob containers and the data, you see there are 0 items found. So folders that we create in the blob storage, these are all virtual. They will only exist as the path of the blob when they have some blobs uploaded in it. So it's really not there unless it has some content in it. Okay. Now you have to click on Upload button to upload a blob. You browse for files. I have got one product.json file that I want to upload. And in the advanced section, if I give a folder name, say product_data, this file product.json would get uploaded into this folder. Now see, the storage browser, it shows the container name as data. It has a directory called product data, and it has a file called product1.json that we just uploaded. Yes, so there you go, back to your containers. Just click on the 3 icons here in the right hand corner of the folder that you've created in the data, which is your product data. If you observe, there is really nothing to show when we go back. So I go back to the containers, data. There's no option coming up, right? Because folders in the flat namespace blob container, these are all virtual. You cannot manage these containers. While on the other hand, if you go to the files and click, there are many options coming up. Now, this blob storage is a flat namespace. If we want a hierarchical namespace, we have to enable it, and then we can use it as a data lake storage. All right, so going back to the storage account, on the left section, if we go to the settings, there is a data lake Gen 2 upgrade option. So just click on this, expand and complete all the steps. Agree to changes. Just observe what all changes. So unsupported blob types, we do not have page blobs here now. Unsupported data protection, container snapshot, soft delete, point in time restore. So these options will not be available when we upgrade it to the data lake setting. We'll agree to all the changes. Start validation. So this will validate if our storage account can be updated to the Azure Data Lake Storage Gen 2. This might take a little time. All right, so the upgrade is successful. Just observe that during the upgrade, the storage account will be offline, and it might take some time if you have large data. And once upgraded, the account cannot be reverted back. So you should be aware of all these changes that we're doing. And now it is upgraded to be used as a data lake, which then can be used for analysis, right? Now we go back to our folder in the container, the product data folder. This has our product1.json that we added previously. Now we click on upload, and we upload one more file. Now we have both the files here. We'll go back to the containers. Now if you check these three icons, you have got to rename permission to this folder. You've got properties to change. We've got generate SAS token. We can manage the access control list for this folder, and we can also delete it. So these options were not available earlier. It's only when you upgrade the data storage to the data lake that these are available. Right? So this is your storage account containers before and after an upgrade. Let's go back to the storage account. In the data storage, we have the file shares. Right? If you click on a plus file share and give it a name, file share, using the transaction optimized, and create. Once it is created, there is a connect option on the top left. If you select this option, you will see there are ways on how to get this file share mounted to your VMs, if it is Windows, Linux, or Mac OS. So these are the scripts that you need to follow if you want to mount your file share to a certain operating system in a VM. And as we have already discussed in the module, that file shares are meant to be mounted and they follow the SMB and NFS protocols. So this way you can handle your virtual machines with the file shares here, right? Let's close this connect pane and go back to our storage account, moving on to our tables. Now on this page, click plus, give it a name. We'll call them products. We've been talking about products all the time. Click OK. There you get the table, and this is the URL that you can access over the internet. So we click on the storage browser, check the tables that we have created. There is a table named products that we just created. Click on the add entity. In the add entity panel, give the partition key and the row key values and add a property. Give it a name. Select the type that you want for the value and provide the value. Add one more property, price, and we'll select double this time and just give a number for the price. Select insert to insert a row for the new entity in the table. Now we have added a new entity in the table. Every time you go and add a new entity, you provide your partition key, give the row key, provide the values, and click on insert. It'll keep on adding new entities in the table. Right? Now, because we have manually entering all this data in the table using the Storage Explorer, the real scenario might look like an application adding data to your Azure Storage Table API, so that you build applications which can read and write values to these tables, which makes it very cost-effective and scalable solutions for the NoSQL storage. Because if you remember from the module, these are tables, these are having entities, but these are NoSQL storage, right? These are non-relational database storage. To have any kind of data stored in the table, you can use these. That's it. That's your storage account. We went through the containers, file shares, tables, and the data lake generation to upgrade. I hope this was useful. Let's move on. With that, We will move on to our second lesson of Module 3, Fundamentals of Azure Cosmos DB. Cosmos DB is a highly scalable database management system. When you hear the word Cosmos, just think of a planet scale database. When I say planet scale, I mean literally planet scale. Obviously, when you want it. It has so many features, I'll talk about the highlights of it here. Azure Cosmos DB supports multiple application programming interfaces, APIs that enable developers to use the programming semantics of many common kinds of data to work with data in a Cosmos DB database. The internal document-based storage structure is abstracted, so it enables the developers to use Cosmos DB to store and query data using APIs with which they are already familiar. Cosmos DB uses indexes and partitioning to provide fast read and write performance and can scale to massive volumes of data. It automatically allocates space in a container for your partitions, and each partition can grow up to 10 GBs in size. Indexes are created and maintained automatically, so there is virtually no administrative overhead. Pretty cool, right? You can enable multi-region writes, adding the Azure regions of your choice to the Cosmos DB account, so that globally distributed users can work with each other with the data in their local replica. Cosmos DB is a foundational service in Azure. Cosmos DB has been used by many of the Microsoft's products for mission-critical applications at global scale. That the list includes the Skype, Xbox, Microsoft 365, Azure, and many others. Cosmos DB is highly suitable for the IoT and telematics because these systems typically ingest large amounts of data in frequent bursts of activity. Cosmos DB can accept and store this information very quickly. The data can be used by analytics server, such as Azure Machine Learning, Azure HD Insight, and Power BI. Additionally, you can process the data in real time using Azure functions that are triggered as data arrives in the database. It's used in retail and marketing as well. Microsoft uses Cosmos DB for its own e-commerce platforms that run as parts of the Windows Store and Xbox Live. And of course, gaming. The database tier is a crucial, important component of the gaming applications. Modern games perform graphical processing on mobile and console clients, but they rely on the cloud to deliver customized and personalized content, like in-game stats, social media integration, high-score leaderboards. Games often require single millisecond latencies for read and write to provide an engaging in-game experience. A game database needs to be fast and be able to handle massive spikes in request rates during the game launches, and of course the feature updates. It can also be used in web and mobile applications. Azure Cosmos DB is commonly used within web and mobile applications and is well suited for modeling social interactions, integrating with third-party services, and for building rich personalized experiences. So, see how interestingly one service can cater to so many markets. That's the beauty of it. As we have already discussed, Cosmos DB comes with multiple API options, and here is the list of all supported APIs that we can use and implement. When I say these available APIs are compatible with Cosmos DB, I'm saying you can just bring on your own databases to Azure Cosmos DB. Let's look at them one by one. The first one is Azure Cosmos DB for NoSQL. This is a native API in Cosmos DB. It manages data in JSON document format and uses SQL syntax to work with the data. This is also the recommended one. Then is your Azure Cosmos DB for MongoDB. MongoDB is a very popular open source database in which data is stored in binary JSON format. The Azure Cosmos DB MongoDB API, it enables developers to use MongoDB client libraries to and code to work with data in Azure Cosmos DB. Next we have in the list is our Azure Cosmos DB for PostgreSQL. The PostgreSQL API is compatible with the open source PostgreSQL database, where you can bring and migrate your database to Azure Cosmos DB. Next in the list is Azure Cosmos DB for Table. The Table API is used to work with data in key value tables. Similar to Azure Table Storage, so the Azure Cosmos DB Table API, it offers greater scalability and performance than your Azure Table Storage. Then we have Azure Cosmos DB for Apache Cassandra. The Cassandra API is compatible with Apache Cassandra, which is a popular open source database that uses a column family storage structure. Column families are tables similar to those in a relational database, with the exception that it's not mandatory for every row to have the same columns. Next up is the Azure Cosmos DB for Apache Gremlin. The Gremlin API is used to have data in a graphical structure in which entities are defined as vertices that form nodes in a connected graph. Nodes are connected by edges that represents relationships. The example on this slide shows two kinds of vertex, employee and department, and edges that connect them. Employee Ben reports to employee Sue, and both employees work in the hardware department. So that's a list of all the 6 APIs that you get with the Azure Cosmos DB. And you select one, whichever is useful to you or whichever suits your requirement. If you're coming new to Azure Cosmos DB, I suggest Azure Cosmos DB for NoSQL as the recommended one. Now we will see a demo where I will provision an Azure Cosmos DB database in my Azure subscription and explore the various ways we can use it to store our non-relational data. If you're comfortable with the pace, you can do this along with me. The instructions can be found on the MS Learn. All right, there we go. All right, so this is your Azure portal. In the portal, we are going to create a Cosmos DB instance. To look for it, just simply click on create a resource and find it, or either just search it on the top bar. I do have it in my recent, so I'm just clicking on here. Create the database account first. So you create a database account first, and the first page is your APIs. You might observe that there are 5 APIs and we covered 6 APIs in the module because the PostgreSQL API is the latest one. Right now we have these 5 APIs and we will go with the recommended core SQL. If at any point in time you want to migrate your MongoDB, Cassandra, Azure Table databases to Azure Cosmos DB, these are your options to check out. Let's go ahead and create a Cosmos DB account. We click on your subscription and resource group. These are the basic details. If you're using a sandbox, they will be already created for you, the Concierge subscription and the MS Learn resource group. Otherwise, if you have your own subscription, just simply click on create new resource group and get ahead. We create resource groups because we want to delete these resources after exploring. So if you delete a resource group, all your resources in that group will be automatically deleted. That's helpful because it saves a lot of time and cost. We have to give it a unique name. We'll just go with our favorite product, sample DB900. And see, yeah, it's available. Location will be happy with the West US. You can choose your location as you want. We're good with provision throughput. So it is giving you a provisioned throughput. So there's a limited throughput that you will get. If you select serverless, the other options will disappear because this is simply pay as you go. So however you use, you will only pay for that. In the provision throughput, you will be charged a certain amount for it actually depends on how data is flowing. So that's a different topic altogether. We do not want to limit, so rest of the things are fine. If you have a free subscription, you can apply this. Next options are just good to go with. We are going with the defaults. There is no need to change anything. Click on review and create. And once the validation succeeds, simply click on create and it'll initialize your deployment. We'll have to wait for the deployment to complete. It won't take more than 2-3 minutes. And then we go back and create our database. Waiting for the deployment in progress. All right, so the deployment might take 3-4 minutes to complete. I have it already done for you. Just go to your Azure Cosmos DB account. On the left side, you will find your Data Explorer right here. In this page, we'll skip the video. We'll just simply click at Launch Quick Start. This will give us a pre-populated settings for a sample database. We just have to click OK. And there should be a sample DB created with a sample container having a partition key -address. So when we're working with Cosmos DB account, you first create an account. Under that, you can have any number of databases. And inside those databases are your containers, which are actually having your data as key value pairs in the JSON format, right? Just as we discussed in the module, you can simply log in and start working with it. Or if you have any other database that you need to sync with cloud, or you want to migrate to Azure, you have any on-prem database which is NoSQL. So this is a really, really good option, and it's also globally scalable. So you can think of using it for a lot of services. Perfect. So we have our sample DB. If you notice in the Explorer, this is your sample DB database with a sample container, and it also has some items available in the table with the ID and the address. Right? This is a unique ID, and this column is representing the items of the addresses, right? Now you select any of these items and you would see a JSON file, key value pair with the address, ID, RID, self, e-tag, attachments. So this is a JSON representation of all the items that you can check. At the top of the page, if you observe, there's a new item to be added. So if you click here and you modify this JSON file, just give it a random ID. Also give it an address. Don't forget a comma. And you give any address. Click on save. So this entry would be a part of this table, And there will be an additional metadata like the RID, which will be added automatically by the table. Now, if you want to query the database, in the same Data Explorer option only, if you go to the query editor, and write your query, you go to the query editor, review the default query, which is the select star from C, and use the execute query to see what it results in. Just review the results, which includes the full JSON representation of all the items, right? Let's modify the query saying we want to see the CID, C address, which we have added with this value. Well, I gave it NEST. So any item which has this address, it should bring as a result I'm going to close it and we'll start over. All right, so that's how you save your items in the database. Now you go back to your Data Explorer page. In the SQL editor, notice the default query. It is select star from C. To run this, click on the execute query button. It will return all the items in the table. This is a JSON representation of all items. We'll modify the query which contains this address, and we'll execute this. And there you go, have it, the entry that we added with the ID and the address. Close the SQL query, discard all your changes. If you observed that you can query your Cosmos DB instances and all those JSON objects or entities as you call it, we can query them with the SQL query editor. And we have already seen now how to create and query the JSON entities in the Cosmos DB database by using the Data Explorer interface in the Azure portal. And if it was a real life scenario, there would be an application developer who would use one of any programming languages, SDKs, or any other application to call these SQL API to add all this data into your container. Because we're doing it manually right now, you don't really do it manually in the real life scenario. It's basically an application interacting with the Azure SQL API for the Cosmos DB. So yeah, that's all that we had to cover in this demo. This concludes part 1 of our session today. Let's recap all the content that you have seen so far. We started off our day with the basics in Module 1, answering questions like what is data, how it looks, and where you store it, the files and the databases. We discussed files and database formats. We saw a few commonly used file formats like delimited, JSON, XML, blobs, optimized files, and the types of databases, the relational, non-relational, and graphical. We learned OLTP and OLAP concepts, and at the end, we covered the roles that one can adapt, like data admin, data engineer, data analyst, with a list of services in Azure that deals with data. Then, in Module 2, we learned some relational database concepts like tables, normalization, SQL concepts, the data definition language, the DDL, data control language, the DCL, and the data manipulation language, the DML, with the basic SQL queries. Then we discussed the services in Azure that helps you build your relational database solutions, like SQL Server on Azure VMs, SQL managed instances, Azure SQL databases, Azure Database for MySQL, Azure Database for MariaDB, Azure Database for PostgreSQL. We also did a demo to provision, configure, and query an Azure SQL database. Lastly, we talked about non-relational databases in Module 3, where we discussed Azure Data Lake Storage, Azure Blobs, Azure Files, Tables as part of the Azure Storage account. We also did our hands dirty creating and exploring the Azure Storage account. Then we talked about the Cosmos DB, where to use it, all of its features, all the supported APIs, and how to create and explore. Pretty much all that we did today. Yay, lots of concepts and a lot of learning. I hope you enjoyed the session as much as I did. Thank you so much for your attendance so far, and we look forward to seeing you next time for part 2 of this Microsoft Virtual Training Days, Azure Data Fundamentals. Happy studying!